Welcome Snoozy friends, to the channel's playlist, Whispers of Our Planets, and the last planet, our Mother Earth. This is part 1 of the final episode series of this playlist, Our Mother Earth. Close your eyes, relax and let's start our journey. One favor from our listeners, please do comment how did you like the video, as it helps us to keep making more. Also like and help other snoozy mates by sharing. Let's begin. There's a moment, in the stillness of space, when the stars seem to pause, as if holding their breath. And in that pause, among the quiet giants and ancient wanderers, a soft light appears. It is not loud like Jupiter. It does not burn red like Mars. It does not whisper in clouds like Neptune. It glows blue, green, and white, in patterns that no other world wears. This is not just a planet. It is home. Imagine drifting far from the solar system, past Neptune, Uranus, Saturn, beyond the reach of the sun's warm voice. Now, turn and look back. There, hanging in shadow, a speck, no bigger than a dust mote in a sunbeam, no louder than a breath. That is Earth, our home, our cradle, our only known oasis. In 1990, the spacecraft Voyager 1 turned its camera back toward the inner solar system and took a picture. In that image, Earth was barely a pixel, a pale blue dot. Carl Sagan, the scientist who helped conceive the image, said this: "Everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives there. And now, so do you, floating gently towards sleep, returning to that pale light with eyes wide in wonder. This is the story of that planet, the only world that sings. Now when the earth was born, long before forests whispered in the wind, before whales sang beneath the sea, before clouds danced through the sky, there was only heat, and dust, and silence. The earth, as we know it, did not yet exist. But she was becoming. Stardust and chaos, the story of Earth begins not on Earth, but in the heart of ancient stars. Billions of years ago, a star exploded. A supernova, releasing heavy elements like iron, silicon, oxygen, and carbon. These elements scattered across space, joining clouds of gas and dust, the raw materials of creation. Over time, these clouds coalesced into a vast, spinning nebula. This nebula, our solar system's nursery, began to flatten into a disk. At the center, most of the material clumped together to form the sun. But further out, in colder, quieter regions, particles began to stick together. Dust became pebbles. Pebbles became rocks. Rocks became planetesimals. These wandering rocks collided violently, drawn together by gravity. With each collision, they grew hotter, denser, more massive. And somewhere, about 4.6 billion years ago, a sphere began to form from this chaos. It didn't have a name yet, but one day, we would call it Earth. Molten beginnings. In her infancy, Earth was unrecognizable. She was molten, a hellish ball of rock, boiling with energy. Meteorites crashed into her every minute, each one adding more heat. Radioactive elements in the core decayed rapidly, generating warmth from within. And so, Earth's surface bubbled and churned like a lava sea. This was a violent time. But even in destruction, something delicate was taking shape. Heavy elements, like iron and nickel, sank toward the center. Lighter ones, like silicon and aluminum, floated upward. This process, called planetary differentiation, gave Earth her first layered structure. A dense inner core, a molten outer core, a thick mantle, and a hardening crust above it all. She was becoming structured, becoming stable, becoming ready. Still lifeless, still dangerous. But the foundations of life were being laid. The great impact. Then came a collision that would forever change Earth. Roughly 4.5 billion years ago, a Mars-sized body, which scientists call Theia, slammed into the young Earth. It was one of the most catastrophic events in planetary history. The energy released was unimaginable, melting both Earth and Theia's outer layers. Debris from the impact was blasted into orbit, forming a fiery ring of rock and vapor. In time, this debris cooled and clumped together, forming the Moon, our closest companion. Born of fire, yet destined to shape the tides and balance our wobble. From chaos came order, and from collision came partnership. A watery gift from the stars, but Earth was still dry. Her skies were toxic, her crust still hot, her surface still bare. So how did the oceans arrive? Scientists believe that water was delivered, not made here. It came in the form of icy asteroids and comets, which bombarded Earth during a time known as the Late Heavy Bombardment, around 4 to 3.8 billion years ago. These icy bodies crashed into Earth, not to destroy, but to seed. Each impact melted into steam. Steam cooled into rain. Rain filled the basins, and the oceans began to form. Drop by drop, century by century, until water covered most of the planet's surface. Oceans not just of liquid, but of possibility. The first breath of calm. As the bombardment slowed, Earth began to quiet. The crust thickened. The skies cleared, just enough for light to touch the surface. Volcanoes still raged, but now their ash made clouds. Their gases, strange and toxic, began to form a primitive atmosphere, full of carbon dioxide, methane, ammonia, and nitrogen. There was no oxygen yet, no breathing life. But there was energy, and water, and time. All the ingredients were coming together. Earth, once a furnace, was cooling, settling, waiting. A planet like no other of all the planets we've visited with spacecraft. None are like Earth. No other world has all three forms of water: ice, liquid, and vapor on its surface. No other world has such a stable temperature range. No other world has an oxygen-rich atmosphere. And no other world, not Mars, not Europa, not Titan, has given rise to so much complexity. From her very first molten breaths, Earth was preparing to become not just a planet, but a world. A place where mountains would rise, where clouds would gather, where rivers would carve paths through rock, where oceans would cradle dreams. She was no longer just a rock in space. She was becoming alive. Drift into the deep past as you rest now. Imagine lying on that young Earth. There is no grass yet. No forests. Only black stone, steam, and wind. The air tastes different. The ground is warm beneath your body. You hear a distant rumble, a volcano exhaling. Overhead, the sky is violet and clouded. But slowly, a blue begins to form. The first oceans shimmer beneath you. The stars spin above you. And deep within the mantle, the earth beats softly, a heartbeat made of magma. She is alive. She is young. And she is waiting for what will come next. Let this ancient memory carry you to sleep. Let the warmth of early Earth cradle your thoughts. And know, you are part of this story. You were always part of her becoming. The ocean that became the sky, the seas arrived before the sky knew how to hold its breath. Long before clouds curled over mountaintops. Long before lightning danced through summer rain. There was only a heavy, stormy stillness. But slowly, in the silence between eruptions, something profound began to happen. The earth began to exhale. The first skies, the early atmosphere was thick and unbreathable. It was born from fire, from volcanoes releasing gases trapped deep within the Earth's mantle. Billions of tons of carbon dioxide, water vapor, methane, ammonia, and nitrogen escaped from underground chambers and rose to the sky. There was no oxygen, no blue, no birds, no breeze. This was an alien world. Yet it was ours. Over time, as the Earth cooled, the intense steam in the air condensed, and the skies began to rain. Not gently, not softly, but with a force the Earth had never known. The long rain, it rained for millions of years. Torrents fell from dark skies, filling the craters, carving the highlands, etching the first rivers into the rock. The earth wept her heat away. She cooled herself, not with snow, but with oceans. The rain gave birth to seas. The seas gave birth to patterns. And with each droplet, the atmosphere slowly began to change. Oceans, the great shapers, with the oceans in place, a cycle began. A system of balance, movement, and memory. The oceans became chemical mixers, dissolving gases from the atmosphere, distributing heat across the surface, absorbing carbon dioxide from volcanic outbursts. They also became mirrors, reflecting the sky, softening the sun, giving the Earth her iconic blue shimmer from space. and they were more than passive pools. The oceans moved, driven by wind, temperature, and salinity. Currents began to flow. These currents would one day carry seeds, ships, stories. But in the beginning, they carried energy. The warmth of the equator was stirred with the cold of the poles. And in that mixture, the first climate systems were born. Winds without wings, with temperature differences between sea and land. The first winds rose. They rushed across the barren continents, lifting dust, cooling lava flows, smoothing the world with each pass. The sky was becoming active, and with it came something else: lightning. Immense discharges of electricity flashed between the sky and ground, each bolt a jolt of energy, each one a possible spark. Lightning wasn't just a weather event. It was a catalyst. Because within the oceans, beneath the electric storms, chemistry was stirring. Earth's early oceans were not sterile. They were filled with dissolved minerals, amino acids, and strange reactive compounds. Scientists believe that in shallow coastal pools, or near hydrothermal vents at the ocean floor, a miracle began. Organic molecules began to form, not just randomly, but in patterns. Amino acids combined. Fatty acids formed membranes. RNA-like strands began to replicate. This was not life. Not yet. But it was the spark of it. And without the oceans, their chemistry, their containment, their calm, none of it could have happened. Sunlight arrives. In the beginning, Earth's skies were so thick that little sunlight reached the surface. But as rain pulled greenhouse gases like coal from the air, the sky began to thin. And finally, light broke through. Sunlight, real, golden, clean, touched the oceans and illuminated the surface. Photosensitive molecules evolved. Some began to harness the sun. And so, the first photosynthetic life emerged. Tiny cyanobacteria, floating in shallow seas. They used sunlight to convert carbon dioxide and water into glucose. And in the process, they released a new gas: oxygen. At first, oxygen was absorbed into the oceans, binding with iron to create rust-red sediments. But after millions of years, the oceans could hold no more, and oxygen began to rise into the sky. The breath of a planet, this was the beginning of Earth's third atmosphere, the one we know today. With time, the sky turned blue, as molecules began to scatter shorter wavelengths of sunlight. Oxygen levels climbed. And high in the atmosphere, something even more important happened. Ozone began to form. This fragile layer of O molecules started blocking ultraviolet radiation, creating a protective shield against the sun's harshest rays. Now, life could safely grow on the surface. Now, the Earth could breathe. A living sky. From that point onward, the skies were no longer just gases. They were alive. Winds carried moisture from ocean to mountain. Clouds formed in the sky's upper reaches. Rain fell on rock, shaping valleys and rivers. Storms churned over open seas, and the seasons began their slow, dependable dance. From pole to equator, from day to night, the Earth became a planet of weather, and each pattern of air, each rising cloud, each whisper of breeze, was a reminder that this world was in motion. Drift on the wind, let yourself rest now. Close your eyes and picture the Earth as it once was. A young world of ocean and storm. A sky dark and full of lightning. Rain falling for centuries. Then, light. A glimmer of blue. A ripple on the sea. A breeze across a rocky shore. And now, life, beginning. Let the thought of those winds guide your breathing. Inhale like the tide. Exhale like the wind. Sleep as the earth sleeps. Not in silence, but in rhythm. A rhythm of water and air, of ancient skies and timeless seas, of calm returning home. He living ground beneath us, before forests rooted into soil, before cities rose on plains, and before we ever called it ground. Earth's surface was in motion. It still is. It creaks. It sighs. It reshapes itself with slow, immense patience. The ground beneath your feet is not fixed. It floats atop something deeper, something alive. A crust that floats. Earth's outer shell, called the crust, may seem solid, but in truth, it is broken. Not broken like glass, but like a puzzle, fitted together by immense slabs called tectonic plates. These plates are enormous, some as big as continents, others as small as islands. They ride atop a softer, flowing layer beneath them. The asthenosphere, a zone of hot, pressurized rock that behaves like thick, slow-moving putty. And just beneath that lies the mantle, a massive region of semi-solid rock that flows so slowly it seems frozen in time. But over millions of years, it moves. And it is this motion that drives the shifting of continents. Plate tectonics, the Earth's gentle breathing. There are 7 major tectonic plates, and several minor ones. They're constantly in motion, though only by a few centimeters per year. Roughly the speed at which fingernails grow. But even this slow drift reshapes oceans, mountains, and life itself. There are 3 main ways plates interact. Divergent boundaries, where plates pull apart. This forms mid-ocean ridges, like the Mid-Atlantic Ridge, where magma rises and cools to create new crust. Convergent boundaries, where plates collide. Here, one plate may sink beneath another in a process called subduction. This forms volcanoes, trenches, and mountain ranges, like the Himalayas, where India and Asia meet. Transform boundaries, where plates slide past each other. This causes earthquakes, like along California's San Andreas Fault. Every earthquake, every volcanic island, every new mountain range, is Earth shifting its weight. The inner heat that drives it all. So what makes the mantle move? The answer is heat. left over from Earth's formation, and from the radioactive decay of elements like uranium, thorium, and potassium. This heat rises from the core in convection currents, causing the mantle to slowly churn. Where hot material rises, plates are pushed apart. Where cooler material sinks, plates are pulled under. This cycle, happening over millions of years, is the engine of plate tectonics. It is also part of something deeper, Earth's way of maintaining balance. The mountains that touch the sky. When two continental plates collide, neither wants to sink. Instead, they crumple, folding and thrusting upward to form towering mountains. The Himalayas are still rising today, growing by about 5 millimeters per year. Each inch of elevation takes millions of years, and yet it continues. Patiently, invisibly, endlessly. These mountains are not just rock. They are climate shapers, drawing clouds and influencing rainfall. They store glacier and control rivers, and over time, they erode, feeding minerals back to the seas. Even in stillness, they participate in Earth's great breathing. Volcanoes, the planet's pressure valves. Volcanoes are more than mountains. They are windows into the planet's deep interior, where plates pull apart or collide. Magma escapes from the mantle, rising through fractures in the crust. When pressure builds, it erupts, sending lava, ash, and gases into the atmosphere. These eruptions have shaped islands, fertilized soils, even altered the planet's climate. The Deccan Traps of India, the Ring of Fire around the Pacific, and the volcanoes of Iceland, each one a mark of Earth's inner voice. And even now, as you drift to sleep, volcanoes breathe quietly beneath the oceans, forming new land in the dark. The carbon silicate cycle, Earth's long-term thermostat. Earth is the only known planet with a built-in climate regulator. It's called the carbon silicate cycle. Here's how it works. Volcanoes emit carbon dioxide, CO, into the atmosphere. This CO dissolves in rainwater, forming weak carbonic acid. The acid weathers rocks, washing minerals into the oceans. These minerals help form carbonate rocks, which trap CO. Over millions of years, these rocks are subducted back into the mantle, and eventually, volcanoes release the CO again. This cycle takes hundreds of thousands to millions of years, but it's kept Earth's climate relatively stable for billions. It is the planet's slow breath, its natural balance, and it depends on plate tectonics to work. Without a moving crust, Earth could not regulate its temperature. She would either freeze or bake. Instead, she remains just right. The foundation for life. Earth's crust isn't just a surface. It's a source. It provides minerals for life, soils for plants, shelter for creatures, and a stage for evolution. The crust's slow recycling through tectonic motion has created continents, river basins, and fertile plains. Its chemistry influences the oceans. Its shape influences the sky. Even magnetism, Earth's shield, is tied to the movement of molten iron below. Without a living crust, we would not be here. Drift beneath the mountains. Now, close your eyes and picture yourself drifting below the surface. You pass beneath a forest floor, beneath layers of rock, beneath ancient sediments marked by time. You pass fossils, buried roots, sleeping crystals. Then, warmth. A slow, glowing current of rock, flowing like syrup, like breath, in rhythms too vast for eyes to follow. This is the mantle, a silent sea of stone. And deeper still, you sense the core pulsing. This is Earth's heart. Not fire, but motion. And that motion gives rise to everything above. Sleep now, as the ground sleeps. Not still, but alive in silence. Let the rhythm of the crust calm your thoughts. Let the drift of plates carry you deeper into rest. Earth is not fixed, and neither are we. We move. We change. We endure. Together, there is a force that surrounds us, but we cannot see it. It moves through every compass, shields every traveler, and dances above the poles in curtains of green and red. It hums softly beneath the crust, within a sea of molten iron. This is Earth's magnetic field, the quiet guardian we rarely think about, yet one that has protected life for over 3 billion years. Let us descend together to the center of the world. As you drift downward, deeper than mountains, deeper than caverns or crust, the world begins to change. Temperatures rise. Pressures increase. The mantle becomes denser, hotter, until at last you reach the outer core. It is not solid. It is liquid. A vast ocean of molten iron and nickel, swirling slowly around the Earth's heart. Here, at nearly 4,000 kilometers beneath your feet, the temperature reaches over 4,000 degrees Celsius, hotter than the surface of the sun. And deeper still lies the inner core, a solid ball of iron about 1,220 kilometers wide. Though just a fraction of Earth's total volume, it holds secrets to our very survival. So how does this inner furnace create a magnetic shield? The answer is motion. As the outer core churns, stirred by Earth's rotation, cooled from above by the mantle, and heated from below by the inner core, it creates powerful convection currents. These currents move molten metal in circular patterns. Now, because iron is a conductive material, its motion generates electric currents, and those currents produce magnetic fields. This process, called the geodynamo, is self-sustaining. As long as the core remains hot and moving, Earth will have a magnetic shield. It is not constant. It pulses, drifts, and occasionally even flips. But it endures, and it protects everything you know. What the magnetic field protects us from. Above Earth is the magnetosphere, a bubble of magnetism stretching thousands of kilometers into space. This field shields us from solar wind, a stream of charged particles from the sun, cosmic rays, high-energy radiation from outside our solar system, coronal mass ejections, vast explosions from the sun that could strip away atmospheres. Without this shield, Earth's atmosphere could have been eroded, as happened to Mars. But thanks to the geodynamo, our air stays in place. Our oceans remain untouched. Our DNA is not fried by radiation. And high above the poles, where the field lines bend and funnel particles inward, something beautiful happens. The aurora, Earth's silent song. When solar particles strike Earth's magnetic field, they are guided toward the poles, where they collide with oxygen and nitrogen in the upper atmosphere. These collisions release light, and thus the auroras are born. Green, red, blue, and purple curtains that ripple across the sky in polar regions. In the north, aurora borealis. In the south, aurora australis. They shimmer in silence, as if Earth is singing her defense. A visual lullaby from our planet's heart. You don't need to see them to feel them. The same shield that creates these lights is the one gently guarding you now. A compass in the darkness. Earth's magnetic field doesn't just protect us, it also guides. For centuries, sailors have used the field to find their way. Animals, like birds, turtles, whales, use it to migrate. They carry tiny magnetic sensors in their bodies, sensing the planet's lines of force like whispers in the dark. Even bacteria, small as they are, align themselves with magnetic fields to navigate through soil and water. It is a language of orientation, a global heartbeat that all living things feel. And you feel it too, though you may not know it. It is steady, it is subtle, and it is ancient. Reversals and mysteries. Earth's magnetic field is not fixed forever. Roughly every 200,000 to 300,000 years, the poles reverse. North becomes south, and south becomes north. These flips take thousands of years. They are not sudden, and Earth has survived hundreds of them. During these transitions, the field weakens, but never disappears entirely. Life adapts. The field regrows. We are living through one now. A slow weakening of the magnetic field. Scientists don't know when the next reversal will come. Perhaps in 1,000 years. Perhaps in 10,000. But the geodynamo continues, strong and steady beneath us. Earth's unseen lock. Some scientists believe the magnetic field may have helped Earth retain her early atmosphere, deflecting solar winds that might otherwise have stripped it away. Mars, by contrast, has no molten core today. Its field is gone. Its air is thin. Its water mostly frozen or lost. Venus, too, has no global magnetic field. though similar in size to Earth. Its surface is a pressure cooker of heat and storms. Earth is unique, not just in what she has, but in what she holds on to. And the field, this invisible blanket of force, is part of that story. Sink into the core. Let yourself now fall inward, through layers of rock and time. Imagine floating above the molten outer core, watching iron swirl like glowing rivers. Beneath you, the solid inner core pulses, a hot, silent drumbeat that powers the world. All around you, invisible lines of magnetic force loop and bend and stretch toward the sky. You are held in the hands of physics. You are wrapped in quiet protection. The aurora swirl in distant skies. Birds migrate on ancient paths. Whales navigate deep oceans without maps. And you sleep, carried by the same silent shield. Earth spins. The core churns. And all is well. Let go into this peace. Let go, knowing that even unseen, you are sheltered. Always. The moon that dances with us. She is not the brightest object in the sky, nor the largest, but she is the closest, and she has never left us. She is the moon, not a planet, not a star, but Earth's shadow twin, and in her silent orbit, she holds our world steady. She shapes the seas, balances the seasons, and marks the rhythm of time. Let's float now into her gentle pull. A violent beginning. The moon was not always there. She was born in fire, a child of impact, roughly 4.5 billion years ago. When Earth was still young, a Mars-sized body, now called Theia, collided with our planet. The impact was catastrophic, so powerful that part of Earth's mantle was blasted into orbit, a glowing ring of molten rock. This ring, over time, cooled and coalesced. Gravity pulled it inward, until it became a single sphere. Our moon, made from Earth's own flesh, yet distinct, always turning, always watching. Why the moon matters. Without the moon, Earth would be wildly different. Her gravitational pull does more than just decorate the night sky. It stabilizes the planet's axial tilt. Earth is tilted at about 23.5 degrees. It's this tilt that gives us seasons. Summer, winter, spring, fall. But without the moon's tug, that tilt might wobble chaotically, shifting from nearly no tilt to extreme angles over time. Planets without large moons, like Mars, experience such unpredictable changes. But Earth remains stable, year after year, century after century, because of the moon. Tides, the ocean's breath. But the moon does more than stabilize. She pulls at Earth, especially its oceans. As the moon orbits, her gravity tugs on Earth's water, creating two tidal bulges, one on the side facing the moon, and one on the far side due to inertia. These bulges result in the high tides and low tides we see daily. They are not small. In places like the Bay of Fundy in Canada, tides can rise and fall by more than 15 meters. And tides are not just movement. They are rhythms that life evolved to follow. The earliest organisms near the shorelines used the tides to feed, to reproduce, to move. Some creatures still do. Even today, the moon keeps time for crabs, corals, sea turtles, and fish. Her gravitational lullaby guides the oceans home, slowing time. You may not know it, but the moon is making your days longer. When Earth was young, a full rotation, one day, took only about 6 hours. But the moon's pull has created tidal friction, a drag on Earth's spin. Over billions of years, this has gradually slowed Earth's rotation to our current 24 hours. And it continues, slowly, even now. At the same time, the moon is drifting away from Earth by about 3.8 centimeters per year. One day, billions of years from now, a total solar eclipse will no longer be possible. The moon will appear too small. But for now, she fits perfectly in the sky. A balance of motion, light, and wonder. Moonlight and memory. Beyond physics, the moon touches something deeper. Our sense of mystery. Her surface bears the scars of billions of years. Craters from impacts. Mountains of frozen silence. Seas that never held water. And yet, we look up at her and feel peace. She glows not with her own light, but by reflecting the sun. Soft, silver, cool. She has inspired poets, dreamers, and navigators. She was the first world humanity stepped upon. And she may be the first world we return to. But even before we touched her surface, we felt her in our calendar. The word month comes from the moon. A month, once tied to her phases. And long before clocks and calendars, our ancestors marked time by her gentle cycles. New moon. Full moon. Eclipses. Harvests. The moon is not just orbiting us. She is part of our storytelling. Part of our culture. Part of us. Earth's only natural satellite. Among all the rocky planets, Earth alone has such a large moon relative to its size. It is roughly 1/4 the diameter of Earth. A rare ratio. Other moons, like those of Mars or even Mercury, which has none, are either too small or non-existent. This large moon contributes to Earth's habitability. Its seasons, its tides, its climate stability. Some scientists argue that without the moon, complex life may never have arisen here at all. She is not just beautiful. She is essential. And yet, she asks for nothing. No sound. No flame. Only her slow dance through our skies. Rest beneath moonlight. Now picture this. You lie on a quiet beach. the sea pulling in and out with the tide. Above you, the moon glows softly. A lantern hung in the darkness. You feel the pulse of the waves. You feel the balance of the planet. You feel the quiet clock of time, measured not in seconds, but in tides. The moon watches over you, as she always has, and you drift gently into sleep, held by the rhythm of her orbit. She is Earth's first lullaby, and tonight, she is yours. Life begins in the waters, in the hush of ancient seas. Before lungs breathed air, before eyes blinked at sunlight, before even memory, something stirred. Not life as we know it. Not yet. But a whisper of it. A molecule, tossed by the tide, wrapped in a bubble of fat, drifting across a warm, mineral-rich ocean. That was all it took. And from that first trembling breath of chemistry, everything began. Earth's oceans were not gentle in the beginning. They boiled under the heat of a young sun. They frothed with volcanic gases and pulsed with lightning from storm-filled skies. But they were rich. A vast broth of minerals, carbon compounds, amino acids, and energy. Scientists believe this environment, warm, active, and chemically rich, provided the perfect cradle for life. Some theories say it began in shallow tide pools. Others point to hydrothermal vents on the ocean floor, where heat and minerals burst from the planet's crust into darkness. There, protected from harsh UV rays, life may have kindled quietly. In the slow reaction between rock, water, and time, chemistry becomes biology. Life did not appear fully formed. It emerged gradually, over millions of years. At first, there were only organic molecules. Amino acids, lipids, nucleotides. Then came protocells. Tiny spheres of fat that trapped other molecules inside. These were not alive, but they were close. Some could replicate molecules. Some could store information. Some could even divide. Then, one day, perhaps only once, a structure formed that could both store genetic code and copy itself. This was likely RNA, a simpler cousin of DNA. And when these early strands found protection inside fatty bubbles, when they learned to copy, change, and compete, life had truly begun. Simple, fragile, but alive. The first true cells from these beginnings, the first true cells evolved. They were prokaryotes, single-celled organisms without nuclei, tiny but endlessly adaptable. Some fed on chemical reactions. Others evolved photosynthesis, the ability to use sunlight to make food. These sunlight catchers were the first cyanobacteria. And their byproduct? Oxygen. At first, oxygen was toxic to many forms of life. But it transformed the planet forever. It filled the oceans, then the sky, paving the way for complex organisms. The Great Oxygenation, about 2.4 billion years ago, oxygen levels spiked in what scientists call the Great Oxygenation Event. It was the first time a living thing changed the planet on a global scale. Many ancient organisms couldn't survive this shift. They faded, leaving behind only fossils. But others adapted. And with oxygen came a revolution. New ways to extract energy. New forms of metabolism. And eventually, new forms of life. The rise of eukaryotes, roughly 2 billion years ago, something extraordinary happened. A small prokaryote entered another. Not to be digested, but to live inside it. This was the birth of eukaryotic cells. Cells with nuclei, organelles, and specialized parts. They were more complex, more efficient, and more capable of evolution. The cell that was swallowed eventually became the mitochondrion, the powerhouse of the cell. This cooperation, this accidental partnership, changed everything. All plants, animals, fungi, and humans come from these ancient mergers. We are, quite literally, collaborations written in biology. From one to many, for over 1 billion years, life remained microscopic. Single-celled. Simple. But then, life learned a new trick. Teamwork. Cells began to stick together. At first loosely, then with coordination. These were the first multicellular organisms. They shared tasks, communicated, and began to differentiate. Some cells gathered sunlight. Others moved the body. Others reproduced. This was the dawn of organisms. True creatures. With shape, purpose, and potential. Oceans full of promise. By 600 million years ago, life filled the oceans. Not just microbes, but soft-bodied creatures. Sponges, jellies, worms, and strange forms we barely recognize. This was the Ediacaran period. A time of mystery, when life began to explore size and symmetry. Then came the Cambrian explosion, a burst of evolution around 540 million years ago. When most major animal groups first appeared, life discovered eyes, limbs, exoskeletons, and nerves. Predators hunted. Prey fled. Life became interactive. And through it all, the ocean remained the cradle. Fins and gills, the first fish evolved in these seas. Jawless and armored, with fins and gills. They were the ancestors of all vertebrates. Every creature with a backbone. Some grew bones. Some grew teeth. Some learned to swim with grace. And eventually, some would grow lungs and legs. But not yet. For now, the story still belongs to the ocean. To tides and coral reefs. To shifting currents and silent migrations. Sleep in the deep, now, let yourself float. You are weightless in the warm, shallow sea of a young earth. Sunlight dances through the water, illuminating fields of algae and drifting jellyfish. Beneath you, trilobites crawl across the sand. Above, soft-bodied creatures pulse gently with the tide. This is a world without sound, without fear, without memory. And yet, it is alive. With every breath, you feel the pulse of life's earliest rhythm. You are part of this story, written in cells, carried through time. Let go, and drift in the waters where it all began. Sleep, as life once slept, before legs, before lungs, before light. Only sea, and silence, and the first, fragile whisper of life. Life comes to land. It was not a sudden leap, not a brave march, not a single step from sea to shore. It was a whisper, a root nudging into moist sand, a leaf uncurling beneath a misty sun, a fin brushing the muddy bank, and pausing just a little longer than before. It took millions of years, but one day life left the ocean, and Earth gained her first forests. The first to arrive, plants, water had always been home. It held life, cradled it, protected it. But eventually, some organisms saw opportunity in the air above, in the sunlight not filtered by waves, in the space not yet crowded. Tiny green algae began to adapt. They developed structures to survive dry spells, to capture sunlight more efficiently, to store water inside themselves. These were the ancestors of the first land plants. The earliest forms resembled mosses, soft and low to the ground, hugging the damp edges of lakes and rivers. Slowly, they developed stems, roots, and vascular tissues, channels for transporting water and nutrients. Then came ferns and lycophytes, and with them, the first true leaves, broad, green, sun-catching sails. The land, once silent, began to breathe. Forests of giants, by 400 million years ago. Forests had spread across the planet. Towering club mosses, horsetails, and tree ferns rose above the soil, some reaching 30 meters tall. They had no flowers, no seeds, only spores carried by wind and water. But they transformed Earth. They held the soil in place. They cooled the air. They absorbed carbon dioxide and released oxygen. More than ever before. With forests came rain, as leafy canopies returned water to the sky. The first soil was born. Crumbled rock mixed with the fallen bodies of plants, rich in minerals and possibility. Land, once barren, became a garden. The first animals on land, before backbones, before scales. It was the insects who came first. They crawled from the water's edge, armored in exoskeletons that kept their bodies from drying out. Early arthropods, like millipedes, centipedes, and wingless insects, began to explore this new world of moss and fern. They fed on decaying plant matter. Some grew large in the oxygen-rich air. Some developed wings, the first creatures to take to the sky. In the stillness of ancient forests, You would have heard the rustle of legs on leaves, the hush of wings over moss. It was the beginning of ecosystems. Food chains, scavengers, hunters, prey. Life was no longer just surviving. It was interacting. From fins to feet, back in the shallows. A new kind of fish was evolving. These creatures had bony fins, strong enough to push against the bottom. Some developed lungs, adaptations for gulping air in oxygen-poor waters. These were the lobe-finned fish, ancestors of all amphibians. One day, and many days after, some of them began spending time above the waterline. First minutes, then hours. Over generations, their fins became limbs. Their gills were supplemented by lungs, and eyes adapted for both water and sky. Eventually, they crawled out fully. The first tetrapods, four-limbed vertebrates, emerged onto land. They were not fast. They were not many. But they were the beginning of all things to come. Frogs, salamanders, reptiles, mammals. Us. Earth breathes above water with every new species. Earth became more dynamic. Rain fell on forests. Rivers carved valleys. Insects pollinated ferns and carried spores. Plants grew higher. Animals burrowed below. Predators stalked, prey adapted, and evolution accelerated. Skies filled with the flutter of wings. Grounds trembled with footfalls. Earth became layered. A vertical world of roots, trunks, branches, and air. For the first time in her history, life moved in 3 dimensions above the ocean's surface. And with it came sound. The chirr of insects. The rumble of thunder through canopies. The hush of wind between leaves. Earth had found her voice. The planet of green, the continents grew lush. From pole to equator, the land wore a blanket of green. Forests covered vast swaths of what is now North America, Europe, Asia. Swamps teemed with dragonflies the size of hawks. Amphibians ruled rivers and ponds. It was the Carboniferous period, named for the rich carbon stored in thick, wet forests. Many of today's coal deposits come from these ancient trees, pressed over millions of years beneath layers of sediment. Earth was not just alive. She was thriving. Air was thick with oxygen. The balance of gases was near perfect. And everywhere, life continued to climb. Sleep beneath a leaf, now. Picture yourself lying in one of these ancient forests. Above, ferns taller than houses stretch toward a pale sky. The air is humid and rich, earthy, soft. Giant dragonflies buzz lazily through sunbeams. The ground is alive with small creatures, shifting beneath a carpet of moss and root. You are still. You are part of the canopy, part of the forest floor, part of the unfolding green of this young land. Let your breath follow the wind through leaves. Let your heart follow the rhythm of rain on bark. Sleep in the arms of a fern. Sleep beside a tide pool gone quiet. Sleep, knowing that life did not rush. but rose patiently, carried by water, then by air. Let the land cradle you, as it cradled every creature that ever dared to leave the sea. Tomorrow, life will grow legs. Tomorrow, the sky will welcome feathers. But tonight, just rest in the silence before the world began to bloom.